All right, here we go. Let's take a look at the next section here. We are going to take a look at basic trigonomic functions, trig functions. I love these bad boys here. This joke here is hilarity. If you don't know the difference between an acute triangle and a right triangle, you may need to go back and look at our geometry stuff. Chapter 7, I think, has all of our trig intro. So hopefully you've seen this before. This is going to be a kind of a quick recap and some new stuff in there. It only works for right triangles. So you have to be the right triangle for me. You have to be the right triangle for this to work. Let's take a look.
Check this out. I want to find this question mark right here. So I want you to take a second, look at these different triangles. I gave you a lot of different triangles, and I had to round slightly in here to make it work. But check it out. Why can we find this question mark given all this information around it? And then we're going to apply that to really everything else we're going to do this section. So pause it, check it out, see what you think. Alright, hopefully when you went through there, you came up with like, yeah, well, they're all right angles and they're 31 degrees, so they're all similar. So you could have come up with some kind of similar triangle thing. So what you could have said is like, oh, okay, the question mark, I don't know the question mark, relates to 70, the hypotenuse there, the longest side. But if I take it to any one of these triangles, I got this ratio like 30 is to 58. So they're always the same ratio. So this idea that 30 is to 58 in this triangle is the same thing as what? In this triangle, that the 33 is to 64. That this ratio is always the same. And it's the same thing in this triangle as 15 is to 29. And then that 21 is to 41. So what's cool about that, if you take these and actually divide these out. So if we divide these out, so 30 over 58 should be, well, it has to be the same as what? 33 over 64. So any right triangle, and again, I had to do some slight rounding on the hundredths, but you can see it's the same idea there. And 15 over 29 is the same thing. And so that one's really good. I did that one well. And that's the same thing as 21 over 41. So these ratios are all the same. And again, a little bit off because of rounding. But these ratios are all the same. So I can find this by saying, yeah, they're similar figures. So they all have the same ratio. So it doesn't matter the size of these. They're the same shape, right angle, 31 degrees. They all have this ratio when you take the opposite side over the hypotenuse. Has that same decimal there, was roughly 0.51 going on. So then we could use that to find, maybe we should find it. We could say, okay, so if we know that ratio, then no problem. We know that, let's call it x is the question mark, over 70 has to equal that ratio of 0.51. No matter which triangle you use, it's 0.51 is that ratio. Then you can just solve this bad boy. Multiply both sides by 70, multiply by 70, and we can say approximately what's half. It's going to be somewhere around half of that. 0.51 times 70 is about 35 degree, or 35 as this missing side here. Awesome. So that's what trig ratios are. Let's go ahead and formalize that a little bit. So let's take a look at this right here. So we're going to put this all together. Trigonomic functions. We have sine, cosine, and tangent. These are our three basic ones we're going to look at. And they're really, a lot of people look at these and say sin, cos, tan. This is a great way to drive Mr. Bean nuts. If you refer to these as sin, you can see like his hair stand up on his arms. It's like fingernails on a chalkboard to him. Cos, he loves when you say cos. It's really sine, cosine, and tangent. So please use the whole thing here. Even though it's abbreviated, we took the E off, so we call it sin. That's quite an abbreviation. But it's really sine, cosine, tangent. So what are these things? Well, if I want to find the sine, sine is opposite over hypotenuse. So the hypotenuse is always the longest side across from your right angle. And in this angle, you look at for theta, here's the angle theta. Across from this is the opposite. So the one it points out is opposite, and the one it touches is the adjacent, or the one that's left over. So the hypotenuse is always the easiest to find. It's across from the right angle. The one opposite the angle, and it changes per angle, is opposite theta. So cosine is what? Cosine is going to be the adjacent side over hypotenuse. And the tangent is going to be opposite over adjacent. Excellent. So this is what our trigonomic functions are. If in this example here, this one I have going, so in my first one, the sine would be what? Letter B over C. This side over this side. The adjacent, this one would be A over C. And tangent would be what? B over A with this picture. So it's always changing depending on what angle we're talking about. A lot of different ways to remember this. I think the most popular right now is this SOHCAHTOA. Oh, yeah, where am I? SOHCAHTOA. So Chief Sakatoa or something, you could remember that way. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. I remembered some old hag came around here taking our apples. However you remember it, it doesn't matter. All right, before we move on, I just want to stress one thing here. If this is side B here, we're talking about side B, then across from it, the opposite is angle B. So we use a big fat capital letter to represent an angle. This is angle B. Across from it would be side B. So if this is side A, what's up here at the top? This would be angle A. And then same thing here. This is side C, little c. This would be capital C down here. So capital letters are the angles. Little ones are the sides, are always opposite. And don't forget the hypotenuse is always the biggest side. So double check that. Make sure it's the biggest side. Always opposite the right angle. So find him first. He's the easiest. But I will ask you to draw some of these where A, B, and C. So make sure little b is across from big B. Little a is across from big A. Alright, notice in this example here, I changed the angle. Instead of using theta, I'm using this symbol here. This is just the Greek symbol for alpha, so don't freak out. We're going to start using some different letters besides theta. So that is alpha. So what's the sign of alpha? So if this is alpha, it's opposite over hypotenuse. So in this case, it's going to be what? It's going to be 5 over 13. Opposite over hypotenuse. Again, hypotenuse is always crossing that right angle. What's the cosine of alpha? Boom, 12 over 13. The adjacent one, the one that touches it. And tangent, opposite over adjacent. So it's going to be the opposite, 5 over 12. So we got to be able to identify these trig ratios. So for this triangle here, that is the trig ratio, 5 over 13. Awesome. Pretty cool. And then we got the last one here, so I try to mix it around here. This is only for right angles. So what we've done is these trig ratios only work for right angles. That we can come up with these things. So here's another one. This little cursive B here stands for beta, another Greek letter. So we'll use alpha and beta a lot. So what's the sign of beta? So again, the hypotenuse always across the right angle. Where's the opposite? Boom, 15 over 17. The adjacent would be for cosine 8 over 17. And tangent would be 15 over 8. Here we go. So let's go ahead and apply this. So we've got these trig ratios. It works for all these different sized triangles and right angles. Can we set up find the missing side? Hopefully so. So I know this is 28. I have to figure out what trig function do I want to know. So this is the hypotenuse. I can look at it and say, oh yeah, you're the hypotenuse across from right angle. This one's touching it, so it's the adjacent. What trig function relates hypotenuse and adjacent? It's going to be cosine. So if you take the cosine of 28 degrees, you're going to get what? The adjacent side over the hypotenuse over x. Excellent. So now we're going to solve this. So what this cosine 28 is just that decimal, just like I did in the first one, that 0.51 of 31 degree angle. That's what this is. And so we're going to use it to solve x. So we have all of them for right angles. We have every single angle. We know that ratio. So if I'm going to solve this, I don't like to have x as a denominator, so I'm going to times both sides by x to get rid of this. Boom and boom. So we're looking at x cosine 28 equals 22. Now I want to solve this, so how do I get x by itself? I'm going to divide by cosine 28. So cosine 28 is that trig ratio. It's just a decimal. If you want to see it, it's in the calculator. All right, so cosine 28 is this. That is the ratio, that 0.8829, whatever. That is the trigonometric ratio that relates them together. So when I go to solve this, those x's, I've got x equals what? 22 divided by that. So all you have to do is type in your calculator, 22 divided by the cosine of 28, and there it is. This would be what my missing side would be, 24.9. And I always double check, is that the longest side? The hypotenuse has to be the longest side. So is it the longest side? Sure, it's bigger than that one, so I think I'm good to go. That is it. So I think you've probably done this before. I want to make sure we understand that they're actually ratios, that we really understand what we're doing here. All right, real quick, before we move on to the next problem, I want to throw something at you. There's probably 2 or 3 people sitting out there thinking, what? I did not get that answer. So sometimes when you're typing these in your calculator, I want to throw this little nugget of information out here for you. You type it in, 22 divided by cosine 28, and you hit enter. Whoa, negative 22.85. Could that possibly be the hypotenuse? Could it be a negative 22? No, no, no. And in fact, what is going on here? Well, if I type in cosine 28, remember before I had that decimal, it's giving me a totally different ratio. Why is that happening? Double check your mode. Anytime you get weird answers, always check your answers. Go to mode and look at what happened here. My calculator switched into radians mode, so I'm in radians. It's doing 24 radians. totally different number than 24 degrees. So always double check that. Make sure you're in degrees. So go ahead and switch over now if you got a weird answer. I don't want you to do the whole rest of the video getting weird answers and freaking out. Can we do it to find a missing angle? Sure, no problem. I want to find x as the angle now. So what do? Well, I'm looking at what? This is the hypotenuse. According to this angle, this is the opposite. What relates these together? Well, that's going to be sine. So the sine of x is going to equal 12 over 20. So how do I solve that bad boy? Well, if I know the ratio here, last time I didn't know the ratio, I knew the angle. I want to know it. So what am I going to do? You're going to kind of do the opposite. We're going to take the inverse operation of this of 12 over 20. That's going to equal x. So to get rid of it, or to put in your calculator, let's clear that out. You're going to hit second sine. So it's the inverse sine of, what was that, 12 over 20. Type that bad boy in. Boom, 36.8, let's say 7. So this will be x equals 36. I'm going to round it to the nearest hundredth, 36.87 degrees. Awesome. So that helps me find the angle. All right, let's take a look at this next one here. So this time I give you triangle DEF is a right angle of angle E. So it's a right triangle with a right angle E. So you have to draw a picture for this one. So instead of giving you the picture, you're going to have to draw it. So I know it's a right triangle. This has to be E. So if this is E over here, this side over here is little e. So capital E is the angle, little e is the side. You can put D and F wherever you want. Doesn't matter. Maybe I'll call this D and this F. Just be careful if that's big D, that's little d. If that's big F, that's little f. So what else does it give me here? Well, I know that the angle D is 62 degrees, so I know this is 62 degrees right here. And I know that side, so it's a little, so it's a side. So let's get rid of that. And let's put a 12 in there. So you have to draw the picture here. Just remember the side is opposite of the angle. So we want to find what? We're looking to find F here. F is this one over here. So what do I need? Well, you can do a couple different ways. I got the right angle here, so you could do it right off the bat with saying what? This is the adjacent, so I could say cosine of 62 is the adjacent. F is what we're looking for over the hypotenuse, 12. Remember, the hypotenuse is always across from that right angle. And this would work, and solve this real quick. Just multiply both sides by 12. Boom. Boom. And those cancel. So what does F equal? Well, I'm going to have to go to the calculator here and say, what is the 12 times cosine of 62? And I'm looking at 5.63. And I always double check to make sure it makes sense. Could that be 5.63 if I put it over here? Sure. How do I know that? Well, I could find F too if you want. If this is 62, what does this have to be? This has to be 28 because these two have to add up to 90. The whole thing is 180. You could do this a bunch of different ways. Now you could have done the sine of 28, but as long as you get this 5.63, this is good. Sometimes I may say solve the whole triangle and make you find D, but it's just one more step. I figure you're good to go on that. Excellent. Moving on. Functions. Hopefully it's a nice review. Let's throw in some word problems here just to make sure we're good, and then we're going to be done with this and done with the unit. Angle of elevation. So this is a perfect angle of elevation problem. All this means is angle of elevation is you got a flat line and something is elevating off of it. So this is the angle of elevation right here. Boom. It always comes off this flat line here. So in our example, we've got an airplane takes off with an angle of elevation. So we've got this runway. The plane takes off. I'm going to draw a little plane up here. Ooh, look at that. That's pretty sharp. That's pretty fancy. It's a nice looking plane. And then we were talking about the altitude of this plane. So it makes a nice right angle. So the key to this is the angle of elevation I got to fill in the number. Let's say it comes off with 12 degrees. So add that into your problem and raise it to an altitude of 1,500 feet. We want to know how far is the plane from the airport via the ground distance. So if it's taking off at this 12 degrees, that's going to go in right here, the angle of elevation. When it gets to this altitude, how far is it from the airport, this ground distance here? So setting up is the hard part of these. Once you get the triangle, you should be good to go, but it's setting up the different things. So what trig function here? I believe we're looking at tangent. And what is tangent? Opposite over adjacent. So we're looking at 1,500 over x. Again, to solve this one, I'm going to multiply both sides by x, and that gives me x tangent 12 equals 1,500. And then I'm going to divide both sides by tangent 12. So again, tangent 12 is just some decimal, some trig ratio. Boom. Old school, we had to look these up in the back of the book. The calculators before scientific calculators. That's how old we are here. I had to flip back and find 12 degrees. It was pretty awesome. So this is 1500 divided by, what are we dividing by? The tangent of 12. Boom. 7,056. So 7,056. Was there a decimal in there? Yeah, 0.95. And that is feet. That's how many feet the airplane would be away from it when it finally got to that altitude. Excellent. So that is angle of elevation. That was not too bad. This is one that seems to trip people up a little bit, the angle of depression. This is just like theta, except that he said, oh, no, I'm just kidding. It's not an angle of depression. Angle of depression, same thing. It's coming from a flat line, but what's tricky about this, it's depressed. It's going down. It's being depressed from here, and it's this angle. It's always from that line of sight. It's always from that straight line. So just like angle of elevation is easy for people to think about coming up, this is the one coming down, and I'll show you why it's tricky here in a second. So here's a building. So I used to teach up on the second floor. So here I am chilling out, hanging out, teaching up on the second floor. Look out the window, and somewhere out here there's a fight going on. So there's a fight going on, but I'm pretty lazy. I want to know how far away is it from the building. If I want to walk out there, I don't want to walk. I'm only going to break it up if it's less than 50 meters away because I'm pretty lazy that day. Pretty great word problem here. And the window's 28 meters high. So let's say I'm up 28 meters in this building. Look out there. And the key is this angle of depression. So angle of depression always comes from your straight line of sight. So if I look straight out my window, it would look something like this. So the key is, where does that 32 degrees go? Well, it actually, a lot of people are tempted and want to put it, well, in my little triangle here, but it's not. It's always from that line of sight. This is the 32 degrees. So it always comes down from the line of sight, something like this. And here's a nice little trick back from geometry. You've got parallel lines, boom, cut by a transversal. Remember, alternate interior angles are congruent. They're the same. So I've got my line of sight is horizontal, the ground's flat. They're both horizontal lines. So if that's 32, this is also 32 down here. So that saves a lot of time if you can do that little trick here. They're congruent. So what am I looking at now? Now here's my triangle. Boom, boom, boom. This is just a nice, easy tangent problem. The tangent of 32 equals what? It equals opposite over adjacent. So just like the other ones, but I kind of want to get some closure here, wrap this up. Let's multiply both sides by x. Boom, they're gone. Then I'm going to go ahead and divide by tangent 32. Divide that side by tangent 32. And we're looking at what? Let's wrap it up. 28 divided by tangent 32. So you get 44.8. And that's 44.8 meters. So am I going to break that fight up? Yes, I am going to do a good job. It's less than 50 meters, so I will break that